Hello everyone. This is our project Physics Mistakes in Paul Blart Mall Cop 2, where we talk about a physics mistakes in the movie. My name is Adam Leidinger,
And I'm Cody Smith.
I'm Jamie Bolak.
I'm Andrea Jakic.
and we're going to go through the physics mistakes and what the error was and how to correct it in the real world.
This report will go into detail disproving an unlikely event in which our protagonist, Paul Blart, in the movie Paul Blart Mall Cop 2, is kicked by a horse and thrown several meters across the street. The team conducted an investigation using the laws of physics, including kinematic equations, Newton's second law of conservation of momentum, and basic Newtonian mechanics to prove the horse kick could not deliver enough force in real life to replicate what has happened in the movie. A video analysis via Logger Pro was used to find the position and the velocities during the scene, confirming the suspicion that the movie did indeed have errors in physics. A kick from a horse could not send Paul Blart 4.2 meters, the distance traveled in the movie dictated by our Logger Pro data, but rather a disappointing 5.5 meters. The following slide shows our movie scene in question. Yeah, right. Following sequence is a breakdown of Paul Blart being kicked by the horse. In the first image, Paul Blart slaps the horse. In the second, he flies through the air far too far, and this is very unlikely. In part 3, Paul contacts the parked car and breaks the window. In this clip, we see the unlikely event, someone getting kicked by the horse. This slide here, in the breakdown, the following sequence shows the most likely emotion after being kicked by a horse in real life. Image 1 shows the first impact. Image 2 shows a person falling back from the kick. And image 3 shows the person after they fall. Looking at the placement of the trees in the background in relation to the horse, we can see that in this one, even though it looks as though he's flew further back, he really only fell roughly a meter back. Here's one more clip reiterating our point.
The first step in the process of proving the physics in the Paul Blart movie scene were incorrect started with a video analysis via Logger Pro. Logger Pro would allow the team to gather metrics such as velocity and distance and that otherwise would be very difficult to obtain. Other metrics were found by web searches such as height and weight of the actor who portrays Paul Blart, Kevin James. This slide shows a table with data from the Logger Pro analysis. It includes position and velocity values of a horse's leg before and during the collision with Paul Blart, as well as the position and velocity values of Paul Blart during the collision with the horse's leg, Paul Blart's flight, and just before Paul Blart hit the car on the other side of the street. The snapshot above shows the use of Logger Pro during the investigation. The yellow line represents the X and Y axis and was set up so that all motion is in the positive direction. The red and blue dots represents the markers the program uses to calculate position and velocity. The green line is scaled reference of actor Kevin James' height during the collision that makes calculations in the program as accurate as possible. The first part of the analysis involved finding the velocity of the horse's leg just before the collision with Paul and Paul's velocity just after the collision. The yellow line on table 1 shows the velocities were 11.591 meters per second for a horse's leg and 11.490 meters per second for Paul. This is interesting because when the conservation of momentum is applied to this collision, it states that the collision was almost a perfectly elastic collision. The momentum of the horse's leg before the collision was almost perfectly transferred to Paul Blart after the collision. Using these velocities, the team was able to find the mass of the horse's leg during the collision.
So on this slide, we're going to be using the conservation of momentum to find the mass of the horse's leg. So using the formula of momentum, we get m1 times v1 is equal to m2 times v2, where m1 is the mass of the horse's leg and v1 is the velocity of the horse's leg right before the collision, and m2 is the mass of Paul Blart times the velocity of Paul Blart right after the collision. So once we solve for the mass of the horse's leg, we end up with 122 kilograms. From our calculations, the horse's leg had a mass about the same as Paul, which doesn't make sense in real life. Using our comparison from a real-world analysis, the people that were kicked by the horse had a very little velocity and traveled a very short distance after the collision. The team expected the horse's leg to have a much smaller mass, which would have resulted in a much smaller velocity of Paul after the collision. From our research, the team estimated that the amount of mass from the horse's leg that actually hit Paul Blart was more like 15 kilograms. Using the conservation of momentum once more and solving for Paul's final velocity, we calculated that he should have had a more realistic velocity of 1.4 meters per second after the horse is kicked. So once again, we're going to be using the conservation of momentum with the same exact formula, but we're going to be replacing M2 with a mass of 15 kilograms. So doing the calculation, finding the velocity right after the collision, we end up with 1.4 meters per second.
In the next few slides, we're going to go over the kinematics that we use to find the distance traveled in the movie and the actual distance that Paul Blart would have traveled given his more realistic velocity. So Paul Blart's velocity was indeed 11.490 meters per second after impact with the horse's leg. How far could he have traveled in that duration of time from the collision to when he hit the car? To find the distance, the team used the following kinematic equation to determine the distance traveled at that velocity, where x initial is Paul's initial position, which is 0, and the x final is his final position, and we were able to calculate that he would have gone 4.2 meters in that duration of time. This calculation of 4.2 meters shows that Paul Blart should have traveled a little farther in that amount of time than the 3.92 calculated from Logger Pro. But they are close enough to say that this velocity is accurate for how far Paul flew. This may have been the only correct thing in the whole scene, that given Paul Blart's mass, his velocity should have been around 11.49 meters per second in order to hit the car on the other side of the street. Paul's velocity after the collision is still highly unlikely, though. He would have had to be hit by a horse leg, or anything for that matter, with an equal mass and velocity in order to travel that distance. It still stands that the horse cannot generate the force necessary to propel Paul Blart 4.2 meters. The likely distance that Paul would have gone, the velocity stated earlier, is 0.50 meters. During the course of our Logger Pro analysis, something interesting was discovered from the velocities of Paul Blart. While Paul Blart was flying through the air, he was subjected to projectile motion, where the only forces acting on him were gravity and a negligible amount of drag. Paul's velocity should have stayed relatively constant given there was no acceleration during that period of the flight. Examination of the data showed that Paul's velocity that did change. During the time interval of 1.44 and 1.68, Paul's velocity actually increased and hit a peak of a 16.919 meters per second, and then went down to 6.09 meters per second at the end of the interval. The only way Paul's velocity could have changed is if there was an outside force that was able to increase his speed and an outside force to slow him down before the impact with the car. This seems to be some kind of movie magic where a mysterious outside force is able to affect Paul Blart's velocity mid-flight. Our team was able to calculate just how much outside force was put on Paul Blart. We calculated the acceleration using a kinematic equation and then used Newton's second law to find the force shown here. So Paul's acceleration would have been 68 meters per second squared, and then we plugged that in to Newton's second law given his mass and found that the force acting on Paul Blart that sped him up and slowed him down was 8,364 newtons.
In summary to our paper, we found that the maximum distance that Paul Blart should have flown from the horse's kick was 0.504 meters. This compared to the Logger Pro data that told us that Paul flies 4.20 meters in the movie shows us that this scene makes absolutely no sense. The force that acted on Paul was nowhere near what was needed to throw him that distance that fast with his weight of 123 kilograms. Another discontinuity we had in our video was a mystery force that acts upon Paul Blart right before he contacts the van at the end of the video. Upon careful observation of the footage, you can see that right towards the end, Paul slows down before contacting the van, and that is able to be seen in our Logger Pro data. Some problems we had in completing this project was determining the equations to use and how to apply them to a problem. Initially, we tried to calculate the impulse of the kick on Paul Blart, but upon slowing down the video, it becomes apparent that the frame rate of the scene is too slow to capture the entire duration of the collision between the horse's hoof and Paul Blart. Had the frame rate been higher, we would have been able to accurately calculate the time interval in which the leg is in contact with Paul. This more accurate time interval would have resulted in better position and velocity data throughout Logger Pro. Hence, we had to use the conservation of momentum and kinematic equations to make our calculations. Other considerations outside of the scope of this course include how momentum is transferred through the human body and the effects of forces on a small surface area such as a horse's hoof.